Hello friends, welcome. Friends, just few days back, that is on 24th of July 2024, there was a press release, the PIB press release released by Ministry of Communication. So this is the date of this press release, 24th of July 2024. So this press release talks about CDOT signing an agreement with IIT Roorkee and Mandi for development of cell-free 6G access points. And it also says it aims to enhance connectivity, signal strength, data speeds to contribute towards 6G standardization, patent and commercialization, and in line with our Bharat 6G vision that aims to establish India as a global leader in 6G technology, driving innovation, connectivity and digital inclusion. So all this is very good and fine, right? But to a layman, this will mean nothing, right? Because this does not explain, even if you go into the description of this PIB press release, if anybody reads this press release, he will not be able to understand anything about what is this technology capable of doing and what are the technical constraints and the physical constraints related to this technology. Now, the purpose of this video is to explain to a layman in simple terms, first, what is this cell-free technology all about, which is being talked about here, cell-free technology, and to talk about the physical constraints regarding implementing this technology in various scenarios. That's the whole purpose of this video, and I'll explain to you in very simple terms without going into any mathematical details or any complexity, so that even a layman can understand. So that's the whole purpose of this video. Now, so what I have done is, in order to make this discussion more efficient, I created few slides. So I'm going to take you through those slides, and I'm sure that you will be able to appreciate what kind of opportunities and challenges exist in implementing a technology called cell-free technology. Now, before I go into talking about the challenges, let's first understand the concept of a normal cellular technology. Because if you look at the description of the press release, I'll go to the press release again. So there is a paragraph which has been marked as bold, and what I have done is I've captured this paragraph in this PPT, and I'm going to read this paragraph before you so that you understand what this paragraph is talking about. It says that traditional mobile technologies uses cellular topologies. Oh my god, my pen. Cellular topologies in which each cell is serviced by a single base station like 4G and 5G. You understand? Every cell will serve a particular customer, and the customer is going to be served by only a single cell, which is written here. And the cell-free massive MIMO technology eliminates the idea of cell. Means it's saying that the cells are completely irrelevant now, right? It eliminates the idea of cell and cell boundaries deployed by deploying several access points across vast region to serve many users at the same time. So everybody will be interested to understand that what is this all about? Means how can the whole concept of cell get totally disappear? So that is the whole purpose of this video, to explain to you in simple terms what is being talked about and what are the opportunities and what are the challenges. So let's go to the first chart. This chart gives you a flavor of the cellular technology. So what is a normal cellular technology? Everybody knows about it. There's nothing much to discuss here. This is a honeycomb structure. So every base station, like if you see the base station number 1, base station number 2, base station number 3. So I have marked every base station using a number, and these base station has got a jurisdiction of coverage which has been marked by this hexagon structure. So every area will be a hexagonal structure, every cell will be a hexagonal structure, and the coverage of this BTS, what is the coverage? The RF signals penetration or reach of this BTS number 1 will be limited to this geography, which is marked by the hexagon. That's the whole purpose of a honeycomb structure of a cellular technology. Means anything which spills over, any signals which spills over to a different honeycomb structure, like if you see this, the red line, and it goes and hits a mobile which is in the jurisdiction of another base station, let's say base station number 3, will be seen as a noise. That is what the concept of honeycomb structure is, that you dissect the geography into these honeycomb structure, and every mobile is served by a different base station. Now, what is the concept of a cell-free technology? Let's look at the concept of a cell-free technology. Now, cell-free technology is doing what? The cell-free technology has these base stations which are located here. You see these base stations which are being marked here, like this access point. Access point is nothing but the base station. Again, my pen is not working. These access points are nothing but base stations. So this is base station number 1, base station number 2, base station number 3, base station number 4, like that. And you have got an user equipment here. There is another user equipment here. So what is happening is that this user equipment, the handset, is going to get served by multiple base stations, not by single base station like what was happening in the earlier slide which I described. So the handset is going to look at this whole network as one single network rather than in a honeycomb structure. That is what this cell-free technology is all about. This is being talked about. So what is happening is that these base stations will be reaching out to the handset, receiving or pumping signal into the handset from different points, because they are going to be located at different areas of the geography. Like some is located in the south side, in the east, west, north, everywhere, and they will be serving the base station, and looks to everybody like a fantastic network where you don't have to depend on a single base station for your service, and that will enhance the quality. That is the claim, that will enhance the quality of the signal and make the signal much more empowering and better, and there will be no dead zone. So what the concept is that these base stations, instead of working in isolation, because normally the base stations will work in isolation as far as the reception of signal is concerned from the mobile, and then later they will talk to the base stations, so the BSCs, the MSCs, the switching centers, all signals will all go into those for the purpose of processing. However, in this case you have a computer here, you see, central processing unit, and the base stations are all talking to this computer and working as if that they are an integrated base station distributed across the geography. Rather than having one single base station, these are all distributed across the geography. It's almost like saying that one base station has multiple arms. It's like a tree, right? So if you basically can visualize a tree which is spreading across an area of, let's say, 1 square kilometer or 2 square kilometer, so you can basically look at in this way, and the tree has got branches. They are all kind of getting converged into the central branch of the tree where the processing happens. And because the intelligence is now centralized, so by this intelligence, every base station, right, will have the intelligence to know which part of the network is much more capable of serving the mobile handset with most efficiency. Because every base station will not be equipped enough to serve the mobiles with full efficiency, because there could be some clutter here, there could be some blockage here. So some base station will be much more properly, or you can say much more appropriately placed compared to the mobile located at that particular point in the network. So now you understand the whole issue, a whole concept about cell-free technology, right? Now, let's look at the cell-free technology, how it works. So I have already explained to you, just give you a premiere, but I will go into a little bit more detail as to how it is envisaged to work. So the way the cell-free technology is supposed to work is that we have got a particular base station, so base station 1, which I showed you there, and then we have another base station 2, right? And then what we have got a mobile phone here. Now, typically, as I told you, that mobile phone will receive signal only for a particular base station which is in the reach of that particular mobile, right? In the coverage area of that particular mobile. The other base station signal will act as a noise. Like for example, this is base station number 1, this is base station number 2, and the distance are D1 and D2. Normally, mobile may be being served by only base station number 1 because the distance D1 is less than D2, and D2 is mobile, the base station number 2 is far away, and therefore it is not going to serve. But in a cell-free technology, both the signals can get combined together as if they are emanating from a single base station. Okay, so this is the concept. Both the signal will get combined, so you will have a better signal compared to only one base station is serving the mobile at a time. Okay, and this they are able to accomplish by having a central processing unit which will be intelligent enough to understand that what is the appropriate signal strength that should be sent by this base station compared to this base station, so that both the signals are received at a similar power level so that they can be easily combined. Now let's come to the challenges, the problems that we have typically in a multi-path system, because this is a multi-path system, right? You see here, this is a multi-path system. One system is emanating from a base station 1 which is located in a different distance, and another base station is located here which is at a different distance, and both the distances are different, right? D1 is less than D2, so this is a multi-path system. Now what are the typical challenges and the problem that we face in a multi-path system, which is explained in this particular slide. Now what happens is that I will not go into very complex detail about how coding is done and subcarrier, carrier, orthogonal system. Those I am not going to talk about because it will going to confuse the whole issue. So let's make it very simple. So we have a signal which is like a square wave, right? You can see that there is a signal. There are basically 3 paths. Path number 1, path number 2, path number 3, because I've showed you only 2 paths there. Let's consider 3 paths, and the signal which gets transmitted from the base station to the mobile is a form of a square wave, right? This is the signal, right? Like this. Typically all signals are going to be like that, right? And it will keep on repeating, and through the repetition it will create a logical connection between the mobile and the base station. Now what happens is that because the signals will travel with the velocity of light, because nothing can travel more than the velocity of light, which is 3 lakh kilometers per second, right? 3 lakh kilometers per second. So per second. So this is the speed. Therefore, if the path 1 is shorter than path 2, and if there is a mobile here where the signal is getting aggregated, then the path 2, the signal which is emanating from path 2 will get delayed by a certain factor which can be, we can call it T. There will be some delay, and both the signals are not going to arrive at the mobile simultaneously. Everybody understand that is very simple. If the path 1 is shorter than path 2 and the signals are traveling at the speed of light, so what will happen is that path 2 will arrive at a time which will be less. Like, 2 people running, one people is running it faster, the other people is slightly slower. So at the finishing line, the guy who actually ran faster will arrive first. So this is going to arrive first, and this is going to arrive a little late, and there will be delay is called, we can basically name it as T. Now normally all systems are designed for this delay, small delay T. And they actually put a buffer bits in each and every stream of signal. They call it cyclic prefix. Now I don't want to get into cyclic prefix. Cyclic prefix is nothing to deal with this problem of this delay, which I explained to you. And this is a complex concept. I don't want to. I'm just letting you know that there is a concept called cyclic prefix. But the cyclic prefix are typically adjusting this delay to an extent of, let's say, around 12%, maximum 15%. So 1/8, So let's say if the duration is of time is t, then you can basically adjust the cyclic prefix in such a way it can deal with a delay which is t by 8, right, or t by 6. That's all. That's how the cyclic prefix are. Because if you put a delay more than this, then the efficiency of the system goes down significantly. So this is the typical problem that we deal with in any conventional system. Now, let's say if there is a path which is significantly far away compared to this path, right? Path number. So path number 3 is significantly far away. So if you see here, the delay that you see in the arrival of path 3 compared to path 1 is out of phase with path 1. Means when it was 1 here, if you consider this as 1, so this is 0. Sorry, this is 0 here and this is 1 here. So it will be a complete destructive interference. So this path cannot be managed, right? So what does it mean? It basically means that the distance of these base stations to the mobile cannot be very diverse in nature. So they have to be tightly placed within a very small geography. If you are going to place these base stations diverse in nature, means it is spread across in tens of kilometers, this whole concept of cell-free technology is not going to work. Now you understand what I'm trying to say. It will be very difficult for this technology to work. So the delay has to be within that particular duration so that it can be managed. Otherwise you can't manage those delay. So there is a challenge here of placing these base stations within a smaller geography, and that smaller geography will be typically around 1 kilometer, 2 kilometer to maximum. It can't be more than that, because if you calculate typically t by 8, and if you take into consideration a 1 milliseconds of I think around it is around, let me just tell you what is the width of a particular typical frame. The typical frame would be around so there is a delay. If you consider the cyclic prefix duration of 8.33 microseconds, right, which is 1 upon 8. So multiply this 8.33. So 8.33 multiplied by 8 comes out to be around 66.44. So that will be the duration of your microsecond of your one symbol, right? So anyway, I will not get into those details. So what I just want to tell you is that in order to manage a delay of 8.33 microsecond, the distance will be roughly around 2.5 kilometers. So it can't be more than that. Okay. So it has to be tightly placed. That is very clear. These things have to be tightly placed. Another challenge that you are going to face is that it can't be at low frequency. Because it has to be tightly spaced, these honeycomb structure have to be because this has to be seen as one single cell structure. You can't have a honeycomb structure. This has to be single cell structure. As soon as these base stations are diversely located at different points in the space, which are spaced apart by more than 2.5 kilometers, then it can't work in a cohesive manner, because of the challenge which I explained to you of cyclic prefix and intersymbol interference on account of the delay. So it has to work in high frequency. It can't work in low frequency, because in high frequency you can limit the propagation characteristics of the radio signal within a small geography, so that these APs can work in a synchronized manner without having that problem of delay, because delay management is going to be a huge challenge. So low frequency, you can't have the signal constrained within a small area of 1 to 2 kilometers. It can percolate and go to 10 kilometers, and therefore you will have huge interference which you cannot manage. The other problem that you are going to face is, because let me just go to this chart, which you will understand what I'm talking about, the constraints of cell-free technology. As I already said, that it has to work in low frequency band, because because of large cyclic prefix will be needed to, and it will undermine all efficiency gain, and there could be destructive interference because of signals emanating from large distances and start interfering with the main signals. In low frequency, MIMO design of antenna is a big challenge. You can't design MIMO in low frequency because the antennas are going to become the AP antenna, the access point antennas are going to become very bulky. And MIMOs always work in high frequencies. Frequency means above 3 gigahertz is the minimum, 3.5 gigahertz is the minimum. But in order for MIMO to work efficiently, it has to be in millimeter wave, which is 26 gigahertz and 28 gigahertz band. Right? That's why satellite, which is working in very high frequency, extensively use this MIMO technique in order to enhance capacity. So you can't operate this in low frequency. So all the low frequency band, the cell-free technology virtually will become useless. Right? Then the most important part is that computational power can be easily managed at the base station level. Like if you've seen this, and again let me go to that slide. So what it is talking about? It is talking about a CPU with high computation capability and machine learning capability, etc. So those you can put a GPU and CPU and all those things in a centralized location and connect all these APs and make this a integrated network by doing all kinds of processing and machine learning and AI, etc., which you can do. But what about at the handset level? Because in the handset level also, same kind of capabilities are required. Why it is required? The same kind of capabilities will be required at the handset level. The reason the same kind of capabilities are required at the handset level is because if you see, the handset has to transmit back to the base station. The handset just can't receive signal. The handset can't just receive signal from the base station alone, right? So it's like the base stations are transmitting signal to the handset here. You see, the base stations are transmitting signals to the handset here in this direction. But the signal is not just unidirectional. Handset has to transmit back to the base station with equal capability. Means the handset should be capable of transmitting signal not only to this particular base station but also to this base station. So there has to be some kind of MIMO capability in the handset as well as the processing capability to understand which of the base stations are optimally located to receive signal. Which means this processing capability which is there in the central processing unit on the base station side, similar capabilities are going to be implemented at the handset level also, which will be extremely difficult to implement because handset cannot have that kind of computational capability. It will be very, very difficult, right, to have same capability as a central processing unit which you can very easily implement at a center. It is actually theoretically possible to implement a capability with that kind of processing so that the whole network acts as a single network with diverse base stations located at different locations. So what will happen is that it will make the downlink path might become very thick using this technology. Though there are a lot of other issues to be dealt with, this is still a theoretical concept. The downlink can become very thick, means your downlink capability can improve in a high frequency spectrum, though it is, as I explained to you, it is necessary, but the uplink will remain the same. Even today, conventional MIMO technology, which is typically used today to serve the mobile handset in 5G, you will find that the downlink have this beam steering capability and all kinds of capability. But uplink doesn't have those kind of capability, and therefore, the uplink is typically always very, very poor. You can say almost 1:12 or even poorer than this, right? Means if the downlink speed is, let's say, 100 Mbps, the uplink speed will be 12 Mbps. Similarly here, implementing an integrated approach from a base station point of view may sound possible, right, at some point of time with advances in AI technology and machine learning technology. But implementing the same thing in a handset level, in a cheap handset level of 2,500 rupees or 3,000 rupees handset is quite a big of an asking, right? So your uplink will always be poorer. And in the today's world, we need a symmetric pipe. We don't need an asymmetrical pipe because there are a lot of data uploading, YouTube videos, reel, etc. The networks are no longer symmetric. So, as the whole purpose of this video was to explain this whole concept in as simple terms as possible, so that you understand the challenges, right, that a typical cell-free technology will face. It's a research area. I'm not saying that this is a completely useless thing to do. It will give you a lot of advantage. Maybe in a situation where, like in case of a Wi-Fi system, the access points are closely located with each other, and they are working at 5 gigahertz, 6 gigahertz. There could be many advantage. Or in a situation where you're talking about fixed wireless terminals, which are not mobiles, right? Which are connected to power, which might have a better computing capability. There, the gains may be very, very significant. But in a conventional mobile, this is a far-fetched idea. I don't think that you will be able to see that kind of gains and that kind of advantage compared to a conventional mobile system, which typically works optimally in a low frequency band, because the coverage is going to be available only in low frequency. By putting so many base stations, today if you look at in India, how many towers we have? We have 8 lakh towers in the country. And putting towers more than these numbers are going to be a huge challenge. And for these access point system to work in unison, you require lakhs and lakhs, millions of towers to serve the mobile handsets, which is a completely impractical thing to do as far as India is concerned. You cannot have so many access points. There will be a lot of challenges, backhaul challenges, optical fiber networks will be required, synchronization will be required. There will be a problem of stealing those access points. Those access points will get stolen. Even in millimeter wave today, we are not able to deploy a dense network. That spectrum is lying completely, free, and nobody is deploying any network there because you can't put so many access points. That's the whole problem. So anyway, friends, I thought of giving you a little bit of a brief as to what the situation is as far as cell-free technology is concerned. There are a lot of research is going to go on in this direction, and people might do very great job. I'm not talking about that, but I thought it is important for me to talk to everybody in simple terms so that they can understand the constraint. So thank you very much for your time. I'll come back to you with a new video next time. Thank you very much for your listening.